Hello everyone, my name is Shajadur Rahman Shanto, and today my group members and I we will be discussing about the BMW supply chain. We will analyze the supply chain for BMW. Starting with the background, uh, it has 31 production and assembly facilities in 15 countries, which results to a global network of sales. It is the world's leading manufacturer of premium automobiles and motorcycles, and of course it is a provider of premium financial and mobility services. We are all fond of BMW to a certain extent because of its design and its outlook. It is flexible and continuous optimization of value chains that ensures competitiveness. It is consistent on implementing the principle of sustainable mobility and is steadily reducing its vehicles' fuel consumption and emissions. As we all know that the customers for BMW keeps increasing every year. And in order to make sure that the customers are able to purchase the product of BMW with uh, with with minimizing the risk that comes along in terms of the environment and many other factors. Now, if we talk about the global supply network of BMW, it has 12,000 suppliers in 20 countries. The production is based on an understanding of the product and production quality. It has a total purchasing volume of more than 60 billion euros per year, which is a lot. The two main focus areas that the company wants to focus is to manage and minimize the risk. As I mentioned, the consumers of BMW should be able to purchase the product, keeping in mind that the risk for purchasing the product is as minimum as it can be. And of course, to take advantage of the opportunities and work with suppliers. And of course, the risks does not only contain the risk does not only involve in terms of the consumers. It also involves in terms of the suppliers. You know, because if the supply is, it could be there could be a lot of risks if the supply is not on time, if there are customer demand and it is not being able to it's not met on time. That time the risks go higher, the consumer demand goes lower. So the risk does not only involve the consumers, it also involves the suppliers and how and when the suppliers supply the products to the designated countries. Now moving on to the next speaker of the group.
Hello, this is Wenhan Zhong, and I'm going to talk about BMW's supply chain. First of all, BMW uses a build-to-order supply chain because each vehicle is customized by every customer. Also, the inventory cost of vehicles is high. In the supply chain of BMW and the automotive industry, there are three tiers of suppliers. Supplier 0 is the OEM assembly plant. Tier 0.5 is the pre-assembled module suppliers. Tier 1 is the sub-assemblies company. and Type 2 is components and parts manufacturers, and finally Type 3 is raw materials and single parts suppliers. At the same time, during the operation of a supply chain, JIT and JIS are both used, especially JIS. JIS is the just-in-sequence strategy. It is implemented by BMW, and it is an inventory strategy that all the parts in an order arrived at the same time and are directly assembled to lower inventory level. Also, BMW is not only under a lean agile supply chain framework, which is adopted from lean supply chain and agile supply chain. This framework share the benefits of both kinds of supply chain and can help to reduce costs and fulfill consumers' personalized customization. And all the above will be discussed later, more specifically in the report.
Now I will introduce our current progress in demand forecasting part. Before we forecast BMW Group sales in Canada from October 2020 to September 2021, we need to choose appropriate methods. According to the graph, we can see that the BMW Group sales in Canada have level, trend, and seasonality. So we can use the following two methods, which are static method and Winters model. In order to make accurate forecast, we need to choose several evaluation parameters to decide the better model between static method and Winters model. The first one is mean squared error, the second one is root mean squared error, and the last one is mean absolute deviation. When these values are very close to zero, the forecast is accurate and the errors are small. Now I will introduce the static method, which contains 5 steps. Step 1. Compute moving averages. Step 2. Deseasonalize the original data. Step 3. Determine seasonal factors. Step 4. Make a forecast based on deseasonalized data. Step 5. Evaluation of forecast. Following these steps, we can get the evaluation parameters for September 2020, which are shown on the slide. Now let's invite Ali to introduce the Winters model.
Now I will continue to introduce our progress. Then we use Winters model to forecast the demand. The main difference between Winters model and the static method is that Winters model has 3 parameters, alpha, beta, and gamma. Alpha stands for smoothing constant for level, beta stands for smoothing constant for trend, and gamma stands for smoothing constant for the seasonal factor. We go through 6 steps to solve this problem. The first step is beginning with the same L0, T0, and final SF from the static method. Step 2 is randomly choosing the value of alpha, beta, and gamma. Step 3 is calculating LT, TT, ST, and FT. Step 4 is evaluating the error of forecast. Step 5 is using Excel to decide optimal level of alpha, beta, and gamma. The last step is re-evaluating the forecast using the optimal level of alpha, beta, and gamma. In the operation of Excel, we use 0.1 as initial choice for all three parameters, using formula to calculate the forecasting value and RMSE, then choosing RMSE as the objective and get the optimal alpha beta gamma when RMSE is minimum. The result obtained using solver is that alpha is equal to 0.11, beta is equal to 0, and gamma is equal to 0. At that time, RMSE is equal to 5.68. After that, we use the values of MAD, MSE, and RMSE to evaluate whether the forecast results are accurate. The closer these values are equal to 0, the smaller the error. The chart below is the result. Then we compared errors of two methods and find that the MAD, MSE, and RMSE of Winter's model are significantly smaller than those of static model. It means that using Winter's model to make forecast is more accurate. Finally, we obtained demand forecast results for next 12 months and compared the data we forecast from October 2017 with the real data. The figure on the left shows the demand forecast for the BMW Group from October 2020 to September 2021 using Winter's model. The figure on the right compares the forecast demand with the actual demand. The yellow line represents forecast demand, and the blue line represents actual demand. The forecast data until 2019 are relatively accurate. It might due to the COVID-19 that has appeared since the end of 2019. There are some errors between the forecast and the real data. In 2020,